review for Precalculus for systems of equations and systems of inequalities and matrices and all kinds of good stuff. So let's get started with some solving by graphing. Okay, so we have number one is solve by graphing. We have some graph paper here. One of our equations is solved for y and the other one isn't. So that's one thing we'll have to do is solve this second equation for y. To do that, we just need to move the x that's in front. Since it's x plus y, we need to do the opposite of a positive x and subtract x over to the other side. So that gives us y equals negative x minus 1. To graph these two things, these are lines, and so they're now in slope-intercept form, which is good old y equals mx plus b. We want to begin with the y-intercept, which is our b, and then our m tells us how to move by giving us our slope, which is rise over run. So on the first one, our y-intercept is 2, so I start at 2, and our slope is 2, but it's not a fraction, and we need a fraction for slope, so we put it over 1. You wouldn't put it over something else because 2 over 2 doesn't equal 2. Only 2 over 1 actually equals 2. So I'm going to go up 2, right 2, because I'm rising a positive number and I'm running a positive number. But I can also go the other direction, so I can go down 2 and left 2. And I find that the more points you make now on your graph, the easier it'll be. Especially if you're not very good at drawing straight lines, the easier it will be to tell where your intersection is, or, whatever. Okay, so the second one, we start with the negative 1, and we're going to go a slope of negative 1, which is 1 over 1, where either the top is negative, or 1 over 1, where the bottom is negative. So the top being negative would be down 1 and right 1. The bottom being negative, we'd say that we'd go up 1 and left 1. A negative slope goes down to the right is also another way of checking to make sure you did a negative slope correctly. So here's my other line. Where they intersect, which is right here, is my answer. That's to the left one and not up or down. So that's negative 1 comma 0. Here's another one, and this time the second one is already solved for y. The first one is not, so I need to subtract x so that I get y equals negative x plus 3. Then the other equation, now a lot of people have problems remembering whether y equals or x equals, which of those is a vertical line and which of them is a horizontal line. Well, it's backwards from what you think. Y equals negative 3 means that y is negative 3 no matter what x equals. And so if y is going to be negative 3 the whole time, no matter what your x value is, that's going to be a horizontal line at negative 3. And then if it was the opposite, if it was x equals something, it would be telling us that x is that number all the time while y is changing. So y is always horizontal, x is always vertical. This other line, which is negative x plus 3, we're going to start at our y-intercept, which is 3, and then go down 1 and right 1. And I'm going to go until I run into the other line. I'm going to make all these points to make sure I run into it at the right spot. So it looks to me like this goes through at 6, comma, negative 3. And to check ourselves, if in the system y equals negative 3, we really already knew what part of our answer was. We knew that this value had to be negative 3. We just needed to figure out what the x value had to be. Now on number 1 and 2, we may have been able to get to the answer faster by substituting or eliminating. The reason we did it by graphing is because that's what the instructions told us to do. And so that's what we had to do to get, if we want full points, if it asked us to do it a certain way. These next two are systems of inequalities, and so the things you got to remember is we are going to shade below when we're less than, or to the left if it's an x, and then above if it's greater than. Also, less than or equal to and greater than or equal to are going to be solid lines, but if it's just a less than or greater than sign without the line underneath, that's a dashed line. Now we need to be solved for y. So on this first one, let's subtract the negative 2x over. All three of these are going to be solid lines, so that's nice that we don't have to worry about that. What we are going to have to worry about is this first one is less than, so we're going to be below the first line. The next one is greater than, so we'll be above the second one. X is greater than or equal to 1 is going to be a vertical line, which I'll go ahead and draw right here. Remember, x is 1 the whole time, is what it's trying to say. And then greater than 1, think about where the numbers are bigger than 1 for x. That happens over to the right. So we're going to be above the first line, we're going to be below the first line, above the second line, and to the right. So we know that we're going to shade this side of this line, but there's going to be two other lines that will affect what's going on there. So y is less than or equal to 6 minus 2x. The 6 is telling us the y-intercept. We're going to go down 2, right 1. And you don't have to make a ton of points, but at least 3 or 4 is good. It is a solid line because it's equal to. Let's just take a second real quick and think about where below this line is. Below this line is this direction. We already know it's supposed to be right of the purple line. So right now our answer seems to be in that general area. But we're going to have to add another line and see what happens. So y is greater than or equal to x minus 3. I'm going to start at negative 3. And then if it's a 1, that's 1 over 1. So up 1 over 1. And so it's above this line. So before that, I had decided, we thought this part was what it was for the first two lines. So now what are we going to do that we're supposed to be above the green line? Well, above the green line is this side. One way you can tell, especially if your line is steep, sometimes it's hard to tell, is if you pick a place on the line you're doing, if you draw up, that's above. If you draw down, that side of the line is below. And so if it's above this line, then we're talking about our answer being right here in this middle area. So what you typically can do is either shade the part that's your answer the darkest. Like if you shaded along the way, you'd shade this part really dark so that your teacher can tell that that's the part you're saying is the answer. Or you could go back and erase the other shading that you did, being careful not to erase the hard work of making your lines or whatever, but you can erase the other shading so that it's really obvious that that inside triangle is what we're going for. This next one's only got 2. We do need to solve them for y. So the first one we just need to subtract x over. And this one will be shaded above, and it's a solid line. And the next one we'll have to add 2x and get 2y is less than 2x minus 4. When you divide everything by 2, it divides everything by 2. So y is less than x minus 2. If we ended up with a negative right here that we were dividing by, you have to flip the inequality. So if this had been negative 2y and I divided by negative 2, this would switch to a greater than symbol. It's just something to kind of be aware of. This is below is where we're going to shade this one, and it's going to be a dashed line. So I'm going to start with that one, negative 2 with a slope of 1, so up 1 over 1. Here's my dashed line. Below that line is going to be this side of my line, because if I just think about putting my pencil on the line and I draw an arrow down, whatever side, whichever half of my graph that arrow is on, that's the side that I'm shading. So that's what I've got so far, is I'm shading down there. Now the other line, y is greater than or equal to 4 minus x. The 4 is your y-intercept. The negative x is like negative 1 over 1. So down 1, right 1. And this one's a solid line. and it is above this line. And so above this line, if I put my pencil on it and draw up, well, that's the top right part of my graph. That's this part. So where did I have shading in common? I shaded this side green and this part purple. They overlap over here in this section. And so that's our answer. So you either need to shade it the darkest, or if your teacher has a preference and like wants you to erase the other shading, that's cool. On both of these, we can actually check our answers by saying, okay, if I think like on number 3 that this is the shaded region, if I pick out a point inside like 1, 1 is inside of that shaded place, if I plug it into my original stuff, it should be true statements like 2 times 1 plus 1 should be less than or equal to 6. Well, that's 3, which is less than or equal to 6, so we're good. The next one is 1 is greater than or equal to 1 minus 3. Well, 1 is bigger than negative 2. And then it says x is greater than or equal to, well, that point isn't actually 1, 1. That point's actually 2, 1. I was not paying attention to where my y-axis was. But x is greater than 1 because it still would have been fine since it's a solid line, but if we put 2 in those places, we still end up with true statements. Same thing can be said over here, that if you count out a point that's over here, it should fit both of the inequalities we have. If it doesn't, then we probably shaded the wrong place. Okay, this is an interesting question because it says to write the system of equations that represents this graph. So instead of giving us equations and making us graph, then we're going to have to work backwards. And it does want us to state the solution. And that's the easy part, I think. We just need to say, oh, well, it's 4, 4. So we know it's the solution. Let's figure out what the equations are. And this one is the easier one. If I have a horizontal line, then that is a y equals line. And if you have problems remembering that, we have a y-intercept of 4. We have a slope that goes up 0 and to the right, and so that means that my slope would be 0. So it's like having y equals 0x plus 4 and saying, well, 0x is going to go away. That's how we end up with y equals 4. So that's, like I said, I think that's the easier line. The other line isn't really that bad, though. We need the y-intercept, which is up here at 8. And then we need the slope. So y equals something x plus 8. So what we need to do is say, okay, well, that crosses at a nice place. Let's find another place that crosses nicely. And you can pick any of these places, and it doesn't matter which one. We're going to count out what it takes to get there. And pay attention to the scale here. If I go down 2, because I go from 8 to 6, then I have to go right 2, because that's from 0 to 2. So down 2, right 2, is negative 2 over 2, which simplifies to be negative 1. If we had picked like this point, we would go down 4, right 4, down 6, right 6. So this whole time we have a slope of negative 1, and you can either write negative 1, or you can just write negative x plus 8. But that's our system of equations, and our solution is 4, 4. Solve the following system by elimination. Show your work. So elimination is the one where we're trying to get the same thing in front of one of our letters with opposite signs, so that if we add the equations together, they'll cancel out, they'll eliminate. It is equally easy to solve for x or y on this, or eliminate x or y on this, because if I wanted to eliminate x, I could just multiply one of these by a negative 1. If I wanted to multiply y, I just have to multiply by 2. It does not matter to me which one you do. So I'll multiply the first one by 2 and get rid of my y's. If I do that, I have to multiply everything by 2. So that's 8x plus 4y equals 20. We're going to add our two equations together. Now we're ignoring this one and just looking at the bottom two. So 12x. This was the whole point of why we did that. Negative 4y plus 4y cancels out. Then it equals 48. So to finish solving, I just divide by 12 and get the x equals 4. Now that I know what x is, I need to get y, because when we solve a system, we're trying to find all the variables. Now, to do that, we can use any of the equations up here that we started with, so try not to mark through them too badly so that you can't read them. It doesn't matter which of any of these three actually equations we plug it into. If one of them seems like it'll be easier, then go for it. I'm going to plug it into the first one, so 4 times 4 plus 2y equals 10. 4 times 4 is 16. Then we're going to subtract 16 from both sides. And get 2y equals -6. Divide by 2. Y equals -3. And so x is 4, y is -3. That is our answer. You can always check your answer by plugging it back into your equations and saying, okay, well, is 4 times 4 plus 2 times -3, does that really equal 10? And then do the same for the next one. If it works for both, then it really is your answer. Solve the following system of equations. It says to show all your work, so let's assume that means that it wants us to do it by hand. Maybe our teacher is really a stickler for being able to do things by hand, so they may not even let you use a calculator on a question like this. So you want to be really careful as you go through this math and do the best that you can. So what we want to do to start is pick a letter to eliminate using two of our equations. It doesn't matter which two you pick. It really doesn't matter which letter we pick. We could pretty easily get there with any of these. For instance, I could do 2 times the first one and eliminate z. And so if you thought of something different that you wanted to do, you could try doing it and see if you come up with the same conclusion we do. And that would be a pretty good way to test to see if you can do it. So multiply all of those by 2. You might try to make your 2's and z's look different from each other. Otherwise, you'll get confused sometimes and think that that says 22 or something like that. And then we're using the second one with that. So what I want to do is 2x plus 2x, which is 4x. -6y minus 1y is -7y. The z's cancel, and it equals 4. Now, this is what a lot of people trip up on. They're fine so far, but then where do I go from here? Because I still have an x and a y. Well, we kind of shelf this for now, and we're going to come back to it later. We're going to go back to the beginning and say, okay, I eliminated z. I need to do it again. So that means that I need to do like maybe the first and third equation and eliminate z. So that's why it's kind of important at the beginning to try to pick a letter that you know you could eliminate more than one way pretty easily. So to do that, I'll have to multiply the first equation by 3 this time. So 3x minus 9y plus 3z equals 3. And then I'm using the last one with it. One of the easiest mistakes to make, by the way, is just copying something down wrong. And so if you are having issues, that's the first thing to check, is that you wrote your equations down right if you recopied them somewhere. And then check for like simple math errors. So now that we have two equations with x and y, we're going to put them together and try to eliminate either x or y. And so as we start that process and say, oh, let me multiply one of these by a -1, hopefully we're going to notice that there's a problem here. And it's really likely that you'll see this problem and think that you've done something wrong. But if you've checked and can't find a mistake, maybe you do the rest of your test or whatever, and then come back to it and try to do it again, and you still get the same thing. Our letters cancel out, which means the left side is 0. The right side is -2. This is not true that 0 equals -2, which means that this system has no solution. And we can stop right there. There's a couple other things that could have happened instead. Let's say that this had been 4 minus 4. Then that would have given us 0 equals 0. And when 0 equals 0, that's infinitely many solutions. So that could have happened. Or we could have actually just gotten that, like, whoops, that was bad. We could have just gotten like y equals 2 or something from this, and when that happens, you go and you plug it back into one of the equations that has 2 variables. That lets you solve for like x in this case, and then you take x and y and plug them back in at the beginning. This is probably going to seem like a weird problem because in class we did a day where we basically took systems and changed them into matrices, and now this is asking us to take a matrix and write it as a system. It says to use x, y, z, and w, and this is also going to seem weird, but because when I guess when people started doing this and they decided to use x and y for whatever reason, then at some point, they added z by saying, okay, what if we have another letter? Well, that's the end of the alphabet. And so after that, we just use W or even some other letter maybe besides W. I think W is pretty standard for your 4th letter though. But it doesn't mean that you write W, X, Y, Z. You don't rearrange it into alphabetical order. You put X, then Y, then Z, then W. And then this last column is going to be the right side of our equal sign. Any place I have a 0 is where I'm going to skip that letter. So I'm going to have negative 9x, y and z gets skipped, and then 8w equals 8. Then I'm going to do the next equation. So 7x minus 9y equals 2. And then negative 5y plus 4z minus 5w equals negative 8. And then 7z plus 9w equals 2. That's our system. It has 4 equations. They don't all have none of them actually have all 4 variables, but it didn't ask us to solve or anything. It just wanted us to write out the system, so we are good. Now, if you're watching this because you're actually in my class and having to do this review, this page may look pretty daunting because we have 1, 2, 3, 4, 5, 6, 7, basically 8 systems to solve. And it doesn't tell you which way to do it, which typically means that you can do it whatever way you want to. And since we learned how to do it on the calculator, the really fast and like very little thought process way, you could technically solve all of these except for 14 and 15 by just putting it in matrices and letting the calculator do it for us. But I would advise you to try to do some of them at least by hand. And I'll show you how to do all of them by hand. And we can talk about how to do it with matrices as well so that you can see that. But do bear with me because I'm going to go ahead and do these by hand in case that's what you decide you want to do as well. Or this is the kind of test that is usually like sometimes you can't use a calculator on it, or at least on part of it, because of the fact you can do all this on your calculator. So on 9, unfortunately, elimination is the easiest way to go by hand because I can't really solve for a variable without getting fractions. I say unfortunately because we're going to have to multiply both of these by something. And so I'm just going to eliminate x, which means I need to do negative 6 and 7, or positive 6 and negative 7. Just one of them needs to be negative. And I'm going to distribute that negative 6 all the way through. I already have this done, so that I don't have to worry about multiplying these, although most of this part wasn't bad. 42x plus 63y equals 105. We're going to add these together, which cancels our x's. We get 33y equals 165, which at first may worry you, but don't worry because 165 divided by 33 does end up being a nice number called 5. Now that we have y, we're going to go back and plug it into one of our equations. And you can plug it into any of these equations, including these two, but it's usually best to pick one of the first two because they typically have the smallest numbers, which means you're less likely to make a math mistake, hopefully. Maybe not, because maybe if it's big numbers, you just automatically use your calculator. Never mind. We're going to do 7x plus 5 times 5 equals negative 10. That's the first equation. 7x plus 25 equals negative 10. So I subtract 25 and get 7x equals negative 35. Divide by 7 and get that x is negative 5. So as a point, that's negative 5, 5. This next one also, we could solve it by substitution actually if we subtract 10x from both sides. So I guess I'm going to do that. And have 5y equals negative 10x plus 10. The reason I knew that this wasn't the worst idea in the world is because I checked and all of these numbers were divisible by 5. And so that means that right here I get negative 2x plus 2. So I didn't get any fractions. If you're going to get fractions when you try to substitute, you should probably just try to eliminate. What we do with that is we're going to use the other equation and put what we got right here, negative 2x plus 2, where y is. So that's negative 8x plus 6 times negative 2x plus 2 equals negative 28. So we're going to distribute 6, which gives us negative 12x plus 12. And then we're going to add our like terms, which is negative 20x, and subtract 12 from both sides. Negative 20x equals negative 40. Divide by negative 20. X equals 2. So this is 2, comma, we don't know what y is yet. So I'm going to plug it, the easiest place to plug it in is right here. You can plug it in anywhere, but this will get us there fastest. Negative 2 times 2 is negative 4 plus 2 is negative 2. So that's our answer. So 9 we did elimination. 10 is an example of how to do substitution. I usually only do substitution whenever either x or y doesn't have a number in front, because then it's really easy to solve because you just have to add the other letter over. But this time I knew it was going to not give me fractions, so I did it just to show you. So there you go. These next two, and maybe we'll just do one of these by hand, and talk about how to use matrices on the other one. So when I look at number 11, I say, you know, the z's are probably going to be easiest because I can do these two together right now and get rid of z. But then the next time I need to eliminate, I can easily do either the first and second or the first and third and get 6 in front of z on this first equation and have it work out. So before I get to the second part of that, I'm just going to add the bottom two equations together and get 4x plus 8y. The z's cancel, and then I get 40. I'm going to shelf that for a second and come back up here and do... I try not to multiply by negatives unless I just really have to. So I'm going to do the first and third and multiply by 2. So that's 10x plus 8y minus 6z equals 52. And then 2x, because I'm using the bottom, plus 6y plus 6z equals 28. So I add these together and I get 12x plus 14y equals 80. And so I have two equations now. That's a 14 right there. I have two equations that both have x and y. So I need to put them together and eliminate another letter. So I can eliminate the x's if I make this one on the left have a negative 12 in front. So that's negative 12x minus 24y equals negative 120. And that gives us negative 10y equals negative 40. So we're going to divide and get y equals 4. Now I know what y is. This is what we didn't have to do on the one we did before because it was no solution. Now that I know what y is, I come back up here and plug it into one of these equations that just has y. So I'm going to pick this one just because I have this room over here. So where y is, I'm going to put 4. And you can skip some of the work on this. Like instead of writing 8 times 4, I could have just written 32. And then subtract 32. But your teacher, if they want you to do this by hand, are going to want you to show most of your steps. And it does make it easier to look back and figure out mistakes, or hopefully not make a mistake if you write your work down. So x is 2. We're going to take 2 and 4 and plug it back in up here at the very top. Doesn't matter which one I pick, so let's just pick the first one. 5 times 2 plus 4 times 4 minus 3z equals 26. Let's see, that's 10 and 16, which together make 26. When I subtract 26 from each side, that makes my number cancel out. I get negative 3z equals 0, which may freak you out at first, but that just means that z has to be 0, because when I divide by negative 3, that's what I get. And that's okay. That doesn't mean that it's no solution. It means that z just happens to be 0. So you can definitely practice 12 by hand, but let me remind you how we could do this on our calculator. I'm specifically thinking of the TI-83 Plus and TI-84 and that kind of calculator. You start by thinking of this as having an X column, a Y column, and a Z column, and then just our right-hand side at the end. And we take all the letters out and just write it down. So like our X column has -1, 5, and -1. I'm going to have to erase that so I can see if it's positives or negatives right there. Okay. Then we do the Y column, which has 5, 3, and 5. Make sure you put the positives or the negatives with them, because that can cause a problem. The -4, 1, and 4, 2, -28, -14. Now I don't have a way to show you what buttons to press on your calculator, but I can tell you what to do. You press this second button, and then on the left side there's a button that says X to -1. You're going to press that because up above it it says matrix, and so it takes us to the matrix menu. On the matrix menu you have 3 choices at the top: names, math, and edit. And so what we need to do is go over to edit and pick to edit matrix A. And when you do that, you want to start off by, at the top, changing the dimensions to 3 by 4. The dimensions are rows by columns, and so there are 3 rows and 4 columns. So you want to make it a 3 by 4 matrix and then type all these numbers in. Double check before you do the next step to make sure all the numbers are written down right, because the only way to screw this up if you're typing it in the calculator is for you to type in a number wrong. Next, you want to do second mode, which should take you back to your normal calculator screen. And then it's almost like we almost kind of repeat the process in some ways. We're going to go back to the matrix menu, so second X to -1. This time we're going to choose math, and we're going to scroll down or up. Up is actually faster, and pick RREF. There is above it a regular REF. Don't pick that one. That one's almost good. But RREF is the best because it gives us the answer without us having to do any work. So you pick RREF, and then it shows up in your calculator screen with an open parentheses. So you go back to the second matrix menu, and under names, you press enter on A, and it should take you back and have A put in here. When you press enter, it should show you a matrix, a new one, and it should have 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the last column should have -4, -2, and -2. And so what's happened is that it's saying that X plus no Y and no Z equals -4, Y without X or Z equals -2, and Z without X or Y equals -2, which means that our answer is -4, -2, -2. (13) You can solve whatever way you want to. It'd be pretty easy to eliminate on this by multiplying by 2. It could be that you want to do it in the calculator to practice, and that's fine. But what is going to happen is this is a special case. 8x plus 10y equals 10. So when I add these two equations together, my x's and my y's cancel, and so I get 0 equals negative 8. That is not true, so this is no solution. The nice thing about no solutions is that you don't have to do as much work because it ends up not working out and then you're done, basically. The next two of these are not linear equations, which means we're going to have to graph them to solve them. I mean, I guess technically maybe you could do it without, but it'd be super difficult and way more effort than you probably want to go through. So I'm going to pull up a graph to show you what it looks like, but it's not going to, it's not going to look like what your graph looks like, but I'll walk you through the whole doing this on your TI calculator for you. You're going to go to y equals and type into the first y equals ln and then put an x in your parentheses. So that gives us part of our graph, and then we do y equals negative 1/2, and you could put negative 0.5 and that'll do the same thing. Okay, and so when you graph this, you can look at and see the intersection, and like, because this is like the coolest website ever, I just have to click and it'll tell me what my answer is, which is awesome. But for the TI, what you're going to have to do is you'll have to go to second trace, and I think it's the 5th option is intersect or intersection. And what it does is it's going to calculate this for you. And just like when you're doing maxes and mins, it asks you 3 questions. It asks you for the first curve, the second curve, and to guess. And as long as what we're doing only has one solution, which in this case, it only crosses once, not more than once, as long as that happens, we usually can just press enter all 3 times and not even worry about it. But if something, like if you try that and it doesn't work, then what you want to do is move your arrow buttons left and right until you get close to the intersection. And so then it should tell you that your answer is 4.844, 1.578. And the same kind of thing is going to happen on the next one, except this time we have e to the x. Oh, not only that, but we're going to have to actually solve the second one for y. So since we're trying to graph, we have to have y equals because that's what the menu says. It says y equals. Now, when you do this, if we're going to put it in the calculator, you can actually go ahead and just, you could leave it like this if you wanted to. If you simplify, you get 1/3 x plus 6. But like if you type in this as a fraction on your calculator, it'll know what you're talking about because it's really cool like that. So let's change these. The first one should be e to the x, and the second one is now going to be one-third x plus 6. And I have to move mine up. As long as you're in a standard window, yours should be fine though. Ah, there, our intersection point. And so again, for using your TI calculator, if that's what you're using, you're going to go second trace and go down to intersect and press enter 3 times, and it should tell you 1.892, 6.631. There's our answer. 16 originally was a multiple choice question, so if it seems like a weird question to you, that's why there was supposed to be an A, B, and a C, and a D. And so if that's the case, that it is multiple choice, you could just plug in the answers to see which one works. This is also really easy to put in your calculator and graph because they're both y equals. Or it's actually really easy to do substitution by saying, well, if these are both equal to y, why can't we just put them together like this? Well, there is no reason not to do that. So if you solve by adding 4x to both sides, well, that's not the one that cancels out. This one is. And then we'll need to add 3 to both sides and get 9 equals 9x, which means x equals 1. Then we just need to plug this into one of the equations and get what y is. Like so, y equals -4 plus 6, which is 2. So the point 1 comma 2 lies on our line. So if we worked that out and then it was multiple choice, we'd look for that answer choice. But you might have found it faster just to look at the answer choices and say, okay, if I put in 2 and 1, does this work? 2 equals 5 times 1 minus 3. Yes, it does. And then you do it over here as well. 2 equals -4 times 1 plus 6. Is that true? Yes. And then you're good to go. 17 asks, a variable needs to be eliminated to solve the system of equations below. Choose the correct first step. So you might argue that there's more than one thing you could do, but only one of these answer choice actually will help us eliminate something just using this. And so if you look up here and you can see that, oh, I just need to multiply the top equation by 3, then look for that answer, which is C. Otherwise, you'd walk through each one and say, okay, if I multiply the first equation by 2, does that make something eliminate? No. Okay, let me look at the next one. And you do process of elimination, whichever way is easier for you. Okay, so matrices, you can't always actually do what they're asking you to do. There's rules, like for adding and subtraction, they have to be the same size. For multiplication, the rules are kind of more complicated. They don't have to be the same size. There has to be the same amount in a row in the first matrix as there is in a column in the second matrix. So let's just get to it. If it says something like this, like don't put undefined unless you're really, really sure it's undefined or have no idea what to do, I guess. But it's really annoying when people put undefined on a whole bunch of problems when it's like, well, you just didn't want to do it, apparently. Anyway, on 18, the trick to this is you either need to multiply a regular 3 into the second matrix and then subtract the matrices, or you can multiply by the whole -3 and then add in between them. Because basically what it's having us do is 4 minus 3 times -5, right? 4 is here, minus 3 times -5. And so that's going to be our first entry. So you could actually even do this all at the same time, because you can do 4 minus 3 times -5, and then 3 minus 3 times 6, then 2 minus 3 times 1, 0 minus 3 times 5. That's going to give us our new matrix, which is 19, -15, -1, and -18. -15, I mean. And that's it. On the next one, so order of operations are going to be important here. It would be, it is better for us to go ahead and take care of this -2 because that's easy, and then worry about multiplying the matrices together. So if I multiply everything in the first one by -2, that's 2, 8, -10, and -10. And then here's how we multiply matrices, and it is a little bit complicated. And here's how we know if we can. This first matrix is a 2 by 2 matrix because it has 2 rows and 2 columns. The second one has 2 rows but 3 columns. To multiply these together, the middle has to be the same number. So we have to have the two things next to each other be the same. And so they are, so that means we can multiply them. Then our answer ends up being the outside numbers. Our answer will be a 2 by 3 matrix, which means it's going to look like the second matrix, that size. So I am going to multiply these, and this is going to take some work. We do the row here with the column here, but the way we do it is we take 2 and 5 and multiply them together, plus then we take the next numbers, 8 and -2, multiply those together. This is the top left entry in our new matrix, and we know that because it is the entry that is the first row and first column, just like what we just put together. So then we're going to do this row with the middle column. So 2 times -4, which is because of this -4, and then 8 times -4 because of this next -4. And then that's the middle top. So then I do this row again, now with the last column. So that's 2 times 3 plus 8 times 5. This is going to give us our first row, and then we're going to do the same exact thing, but now with the bottom row. So I'm going to use -10, -10 with each of these columns, just like what I did before. So -10 times 5 plus -10 times -2. Then I'm going to do -10 times -4 plus -10 times -4. And then the last one, -10 times 3 plus -10 times 5. And we just need to do each of these separately. Like if it would help, like these are all, there's 6 different numbers we're trying to find now. And those numbers are -6, 40, -40 I mean, 46, -30, +80, and -80. If you are allowed to use your calculator on a problem like this, what you can do is you can type the first equation into matrix A and type the second one into matrix B, and then on your calculator screen you can tell it, kind of like how we put RREFA, you can say, hey, do A times B, and it should tell you that this is the answer. The next one, now this is an order of operations issue. Do we multiply by -4 first, or do we add first? Well, parentheses come first. We need to add these together, which is 7, 0, 6, -5, and then move the -4 in, and so everything gets multiplied by -4. If you could have just multiplied everything by -4 to start out with and then added, but technically, not technically, it doesn't really matter which way you do it as long as you do it one of those two ways. And finally, which comes first, addition or multiplication? Definitely multiplication. This is 2 by 3 and then 3 by 2, and so the middle numbers match, and it's going to give us a 2 by 2, which is good, I guess, because that means we'll be able to add it to this first matrix. I said I guess because this would be easier if it didn't work, because then we would just say it was undefined. But right now we're just going to not worry about this. Don't actually mark it out on your paper, but we're not going to worry about that part until we're done with the second part, which is multiplying. You don't have to write everything down that I did on the first time we did it. If you can do it in your calculator in your head, but we want to do -3 times 1 plus the middles, so 3 and -4, plus the last, so 6 and -3, That's going to be our top left entry. Then we're going to do first row and second column. So -3 times -3, 3 times -6, and then 6 times -6. Then we'll do the bottom the same way. So see if you can maybe do those on your own, like pause the video and see how it goes, so you know if you've got this right or not. And so then the next one is going to be the bottom. So 5 times 1 plus -6 times -4 plus 4 times -3. And the bottom row with the second column, 5 times -3 plus -6, -6 plus 4 times -6. Now, I could definitely really easily have written something down wrong. What I should get is -33, -45, 17, -3. And so now I come back and have to add that with the first matrix that we just left alone. Because if I multiply these two together, we're still adding it to the first matrix. So I just need to, when I add, I do each element together. So 3 and -33 is -30. And then -6 and -45 is -51. Then 14, then 3. And that's it, we're done.